Hello everyone, myself Syed Sohail Ahmed. I'm from Civil Branch. I'm here to say about potential evapotranspiration. My roll number is 20951804142. So let's begin. First of all, let us know what is potential evapotranspiration. Potential evapotranspiration or PET represents the combined loss of water through the plant's process of transpiration via its vascular system. Um, evapotranspiration can be defined also as evaporation of water from the Earth's surface. Both are influenced by temperature, humidity, sunlight, and wind. So, evapotranspiration is nothing but uh, the plant the plant's process of transpiration via its circular system or evaporation of water from the Earth's surface. Both are influenced by temperature, humidity, sunlight, and wind. That is transpiration through vascular system or transpiration through temperature or humidity or sunlight or wind. Now let us know what causes potential evapotranspiration. The rate of evapotranspiration PET is nothing but the amount of water that could potentially be lost to evaporation or a vegetated surface given meteorological condition at the time is dependent on the intensity of solar radiation, air temperature, humidity, and wind speed. So we can say that evapotranspiration depends on temperature, solar radiation that is nothing but solar radiation that is nothing but sun rays, humidity, and wind speed. These are the reasons which causes potential evapotranspiration. In this, we can see transpiration, evaporation, and groundwater recharge. Transpiration from leaves, humidity and temperature, and evaporation from groundwater or soil or available water. Now let us know about what is the difference between PET and ET, that is potential evapotranspiration or evapotranspiration. Potential evapotranspiration PET is defined as the maximum amount of water that can be removed from a land surface through evapotranspiration as sum of both evaporation and transpiration given abundant supply of soil moisture. In other words, the removal of water by ET depends only upon the available energy. So, potential evapotranspiration is nothing but evapotranspiration in some particular time. That is, evaporation and transpiration given abundant supply of soil moisture. We can also say that the removal of water by evapotranspiration depends only upon the available energy, thus causes potential evapotranspiration. Methods to determine evapotranspiration. Methods for evaluating evapotranspiration can be divided into three categories: hydrologic or water balance method, analytical methods based on variables, and empirical estimates. The water balance method to determine EV, that is evaporation, consists of catchment hydrology, soil water depletion sampling, and lithimetry testing. So, by the methods that are analytical method based on climate variable or empirical estimates, or catchment or hydrologic or water balance method. By these three methods, we can determine potential evapotranspiration. These are the commonly used methods to determine the potential evapotranspiration. Methods for evaluating evapotranspiration can be divided into three categories: hydrology or water balance methods, analytical method based on climate variable, and empirical estimate. These are the three methods by which we can determine potential evapotranspiration. The water balance method to determine evaporation consists of catchment hydrology, soil water depleting sampling, and lysimetry testing. Catchment soil water depletion sampling, and lysimetry testing are uh, consisted to calculate evaporation. Device used for determine potential evapotranspiration. Atmometer is device that is used to measure the rate of water evaporation. It is also known as evapometer. Atmometer is a device that is used to determine the rate of evapotranspiration. In other words, we can say that evaporimeter is used to determine the potential evapotranspiration. Which climate type has the highest potential evapotranspiration? Dry climates. The most obvious climatic feature of this climate is that potential evaporation and transpiration exceed precipitation. These climates extend up to 20 to 35 degrees north and south of the equator and in large continental regions of the mid latitudes, often surrounded by mountains. There is a particular climate in which the rate of potential evaporation potential evapotranspiration is high. That is, in dry climates, the rate of potential evapotranspiration is high. Because of 20 degrees to 30 degrees temperature, the evapotranspiration rate will be high. In other climates, such as cool climate or rainy climate, the evapotranspiration will be low. That is because of low temperature. In low temperature, there will be low rate of evapotranspiration and even the low rate of potential evapotranspiration. In dry climate, uh, if the temperature exceeds from 35 degrees, the rate of evapotranspiration will be very high. Because of the high temperature, we can see the high rate of potential evapotranspiration. So finally, we can come to a conclusion that evapotranspiration process draw heat from surface when converting liquid moisture into vapor. It therefore provides a mechanism to mitigate the urban heat island effect. So we can say that transpiration and evaporation combine and form evapotranspiration. Evapotranspiration draw the heat from the surface, that is from the groundwater, which is extracted from soil or the available water such as lake or river or pond, etc. From this, uh, the heat from the surface when converting liquid moisture into vapor, it therefore provides a mechanism to mitigate the urban heat island effect. So we can say that evapotranspiration process draw heat from surface when converting liquid moisture into vapor. It therefore provides a mechanism to mitigate the urban heat island effect. So this is all about potential evapotranspiration. Thank you.